Located high above these clouds, a dormant volcano towers 7,400 meters above the bottom of the Pacific Ocean. This, the tallest volcanic peak on Earth, is considered sacred by the indigenous people surrounding it as the most sacred region of the benevolent spirits and the home of Poli'ahu, the deity of snow. This Hawaiian volcano is called Mauna Kea, a shortened form of Mauna Wākea, which means Mountain of the Sky Father. It is here that astronomers from around the world have crafted a tenuous agreement with the indigenous people that allows the astronomers to build and maintain their telescopes high above most of the lights and air pollution that envelop our home planet. I'm Ron DiUlio, and I will be your tour guide around this awesome site. I will be joined by Dr. Ohad Shimmer, the staff astronomer for the University of North Texas, and the principal investigator for one of the most far-reaching research projects ever attempted, a Gemini large and long program that will extend over the next 3 years. I did say far-reaching, didn't I? We begin here at the Gemini Observatory. Dr. Shimmer, can you please describe what this project is about?
We were recently awarded 350 hours of observing time on Gemini North in Hawaii, one of the world's largest telescopes. This is to observe more than 400 distant quasars and obtain their infrared spectra.
While we've heard the term quasar, can you elaborate on the nature of these objects?
Quasars are the most luminous persistent sources in the universe. They shine brighter than 1 trillion suns, and as such they serve as cosmological signposts. These cosmic powerhouses form when gas is funneled toward giant black holes at the centers of galaxies.
What are the main goals of this project, and what are the projected outcomes?
The Gemini observations will lead to better estimates of the masses of the quasars' black holes, their fueling rates, and their distances from Earth. The results of this project will help us develop improved equations for these key properties for all quasars. The next generation of cosmological surveys will generate millions of quasar spectra, the analysis of which will greatly benefit from the prescriptions developed in this investigation.
Why is it important to study quasars?
Quasars consist of growing black holes millions to billions of times more massive than the Sun. Since quasars are thought to shape the growth of their galaxies, better understanding these sources is one of modern astronomy's major goals.
I can see that below the Gemini telescope is mounted the largest infrared spectrograph in the world. Why this system?
We need the Gemini observations because they will provide us with superb infrared spectra of these distant sources, and these are needed to observe key features in the quasar spectrum.
By the way, can you please explain what you can learn from an object spectrum?
An object spectrum is like its fingerprint. It can tell us about the object's composition, its temperature, how fast it's moving, and other key properties.
How would you describe the overall scope and significance of this project?
Some 350 hours of infrared observations of more than 400 distant quasars with the Gemini North Telescope in Hawaii will produce the best and largest dataset of its kind. The Gemini project involves more than 20 scientists from all over the world, including key researchers in quasar science, and the results of this project will help us place distant quasars in perspective, which means we will be able to better tie the properties of these distant sources with those of the more common nearby quasars.
The next 3 years should provide some exciting new information about quasars. I'll check back then with Dr. Shimmer to find out how it went.